Welcome back friend, this is our 5th class and in this class we will learn about MPC, that is a multi-purpose controller. This class is divided into 2 chapters. This is the first chapter and these both chapters are going to be very interesting. So, let us get started. Learning objective. Following topic we are going to cover in this chapter: what is MPC, what is MPC 10, difference between MPC and MPC 10, MPC card familiarisation, MPC card specification plate, terminal J10, MPC card connections, type of defects in MPC, how to rectify defective MPC, how to reset MPC. So, now we are going to see the definition part of MPC. The MPC, this is a kind of PLC, that is a programmable logic control. As name suggests, it is used for various jobs. That means same device is used to function differently in different place. Repeating, same device is used to function differently in different place. That means hardware is same but software is different. In ME engine, MPC is used as EICU, CWCU, ACU, CCU, SCU, ECU, SCR controller etc. It has been jointly developed by MAN B&W and Mitsui. It was first developed by Toshiba, a Japanese company. So, we are now going to see the example of MPC. For example, one MPC is there which is being used in boiler automation, as well as same MPC is also being used in operating lifts in the building. For example, this is the MPC, this is being used for the boiler automation and same MPC is used for the lift. So, here you can see that same MPC works different at different location. Just what you need to do is change the software. So, I hope you understand that how the MPC works. Now, moving to our next topic, that is the type of MPC for ME engine. There are 2 types. One is MPC 10 written over here, another is MPC. This is called the MPC multi-purpose controller and that was multi-purpose controller 10. Now, moving to our next topic, that is a difference between MPC and MPC 10. So, here I have summarized some differences. MPC 10 size is this much, weight is 2.5, cabinet is this much. Cabinet means the box in which this MPC 10 can be accommodated. It has 20 external connector. It is shelter electronics. Shelter electronics means this unit is basically sealed with the metal plates, you can see over here, whereas this unit is not sealed. Okay, you can access all the parts. So, now MPC size is here, weight is 4.2 kg, cabinet 500 into 400 into 210 mm. It has 55 external connector and no shelter electronics, means you can access any part of this MPC. Now, moving to some other differences. MPC 10 optimized cylinder control unit, MPC multi-purpose controller. Optimized cylinder control unit means this MPC 10 is used only as a CCU. It cannot be used as a ECU, EICU, SCU, SCU etc. Only CCU. Okay. But here MPC can be used as any of the parts like EICU, ECU, CCU, SCU etc. Size is this much, size is this much, weight 2.5, weight 4.2 kg, cabinet is this much, cabinet is this much. It has 20 external connector, 55 external connector, no accessible electronics, I have already explained. Exposed sensitive components means all components you can access easily. EMC cable rail, easy fast, EMC cable glands difficult. A standard cabinet means the cheaper one is installed in the MPC 10. Here the EMC cabinet, which is very expensive. In MPC 10, simple EMC design is there. and here in MPC complex EMC design is there. Now you might be wondering that what is EMC. So now I am going to explain about EMC. EMC actually stand for the electromagnetic compliance or compatibility. Now we will see the examples and definition of electromagnetic compliance. The electromagnetic compliance is a property of any electronic system which mitigate the effect of any electromagnetic wave caused by itself or by others. Basically it nullifies the effect of the electromagnetic wave, which basically generate the noises and ripples. Cause of the electromagnetic interference. So radio wave, audio wave. Radio wave means when we use a walkie-talkie, then radio wave generates. So this also can hinder in the function of the MPCs. Audio wave means any sort of audio wave means suppose you are using any audio device, then it may also interfere with the PLC. Next is electromagnetic pulses from system itself. A nuclear reactor wave means your ship is passing through any nuclear reactor, then surrounding to the nuclear reactor you might face some electromagnetic wave. So this is also a cause. Another one is operation under high frequency. If a conductor is carrying very high frequency, then unwanted electromagnetic waves generates and they can hinder in operation of the some PLCs. Okay. What are the remedies? Remedies is that EMC circuit design. EMC circuit design means conductor which are carrying high frequency, you have to isolate that one. Next is selection of correct category of wire, means if wire is not suitable, then obviously some ripples and noises will be generated. Second thing is harmonic wave filter. Harmonic wave filter basically equipped in the circuit which nullifies the electromagnetic wave effect, and it look like this. You might have seen in some electronic PCB. So next is capacitor. So capacitor also act as a filter which bypasses some unwanted waves and allow to pass only which is required. Now here you can see that capacitors are installed at so many places. These yellow colors are nothing but capacitor. Okay. Next is earthing of the cable. This is very important, and now we are going to see in detail about this earthing of the cable. Here you can see that these are the conductor, and this is the metal shield, or we can say metal cover, which is basically used for electromagnetic compliance. Now how this is used we are going to see. Here you can see that this is armor and it is tied by a cable tie, and by doing this, this metal armor comes in contact with this metal plate and hence it get earth. So any ripples or any sort of electromagnetic wave will be grounded, and hence interference of these waves are nullified. Next is here this is the connection of the gland. This is complex design. So you can see this metal armor is designed like this one, and when we tie this cover, then this will have a connection with this metal part. This is the nipple, and ultimately it will be earth. Next design is this is little bit complex design which is mostly used in MPC. Springs are given. These springs are basically used for the anti-vibration mounting, and here metal plates are clamped on the armor, and that is how this electromagnetic compliance is achieved. Now next is, this is just example, this is MPC, and here you can see that this is the armor and this is tied with the cable tie which bring this one in contact with this metal plate, and ultimately this grounds any unwanted frequencies, and hence we can achieve the electromagnetic compliance. So I hope this electromagnetic compliance is clear. Now we are moving to our next topic, that is in MPC 10 there are no heavy components. In MPCs many heavy components, like you will find lot of relays and heavy CPU is there. It has only one main fuse, that is 3.15 ampere, and it has total number of 14 fuses. Now I am going to give example. So here you can see that this is MPC and there are so many fuses installed in the MPC, whereas in the MPC 10 you will find only one fuses installed. Now moving to next, in MPC 10 multifuge is replaced by registers, and in MPC heat sensitive multifuge, that is a PTC, is used. Now you can see this is a picture of the multifuges, and this sort of multifuges are being installed in the MPC. Now you can see that this is a picture of different capacitor. So this multifuges and this capacitor look similar. So question is, how will you come to know that this is multifuges or capacitor? Like some value of capacitance will be written over here. Here it is written 102 15 kV, etc. But here on this multifuges you won't find any some sort of data, means you will not find voltage and all that. You will find only the temperature and some other values that is not relevant of capacitance. So by seeing this you can identify. Other thing is that these multifuges are very thin, whereas these are a little bit thicker. So by these two way you can identify that which are the multifuges, which are the capacitor. Now moving to next, that this MPC 10 is having the no programmable input, and in MPC lot of programmable inputs are there. Now question is, what is programmable input and what is non-programmable input? So in order to understand that, we are going to next topic. So here this is just example of the MPC 10, and here you can see that analog input and digital inputs are given. In the analog input, it can read only 4 to 20 milliampere in all channels, whereas in digital input it can read only greater than 20 or less than 20 volt in all channels. Okay. Now in case of MPC, if I want to make this channel read only from 4 to 10 milliampere, I can do that. This channel, if I want to read from 10 to 20 milliampere, I can make. Similarly, in digital input, if I want that this channel should read from 15 to 20 volt, that means below 15 it will sense 0, and between 15 to 20 it will sense 1. Similarly, here in this channel I will make it to read between 5 to 10 voltage. So I can customize depending upon my choice. So that is called the programmable inputs, and that can be done only with the help of software. So here in MPC 10 everything is fixed, you cannot change, but here in MPC it is variable. So this is the difference between the programmable and non-programmable inputs. Now moving to next, that is MEB support 1 per cylinder and MEB support 1 per 2 cylinder. So here this is a picture of MEB engine. Here you can see these are the two booster unit, one for each cylinder, and here exhaust valve actuator are there. This exhaust valve actuator basically driven by the camshaft, but these two booster unit driven by the CCUs. So now in MEB, if I use MPC 10, then I have to use two MPC 10, one for each booster unit, whereas if I use MPC, then I have to use only one MPC for both these booster unit. So in that way I can save lot of money by using this MPC, because I have to use only one, whereas in case of MPC I have to use two. So now moving to next topic, that is price reduction of minimum 40%. This MPC 10 costs around $4,000 and this MPC cost around $7,000, and hence reduction of price is about 40%. Now we are going to our next topic, that is the MPC card familiarization. So this is our MPC. This is called the main power input socket from UPS A and UPS B, means 24 volt DC comes from the UPS A and UPS B, and this is the main power input socket. Next is this is called the power card. Power card is used to control the DC 24 volts power supply and supplies to all other cards. Now next, this card is called the input output card, and this card is called the daughter or child card. So now we will see it from the right side. So here we can see that this is our power card, this is our main PLC motherboard card, this one is, this is input output card from here to here, and this is the daughter card from here to here. Okay. Now these all socket which you are seeing, these are called as socket, as a channel and as junction. So if I tell you that this is a J42, this one is J42, that means I can say it that socket number 42, channel number 42, junction number 42, like this. So I hope this is clear. Now moving to our next topic, that is a MPC specification plate. This is MPC specification plate. Here the same thing on MPC. So this specification plate basically tell about the position of channels, that where are they located, and about fuses. It also tell about the rating of the fuses. You can see here that F1 is 12 ampere, F5 to F8 2 ampere, like that. And other function of this specification plate is that it is used for the marking. So you can see here that marking have been done. So when you will do the marking is done before swapping or changing the MPC, so that you should not do mistake. Now we are going to next topic, that is all about fuses. Here in this section we will learn about all fuses which is installed in the MPC. Here this one is called the main fuse and nominated as F1, and here these are called the auxiliary fuses. So now here we are going to see all fuses one by one. First of all we will see about the fuse F1. F1 is here, this is connected with the main power junction J1. Now comes to F11. F11 is located over here and it is connected with the J2. This J2 is used for the power failure. Power failure means it is basically used for the alarm. Okay, you can use it for alarm purpose for the other system by using the relays and contactors. Okay, now moving to next F3 to F9. So here it is F3. F3 is connected to J3 and F4 is connected to J4 and so on. You can see here, and last F9 which is connected to J9. So these are basically supplying the power of 24 volt DC, and this power is supplied to source plate pump, FIBA, ELVA and LFI. So these are basically supplying 24 volt DC power to all these equipments. Now we will see it in the electrical diagram. So here this is the electrical diagram. So you can see J9, that is written over here power, means this channel is used for the power, and here you can see 0 to 24 volt DC is coming out, and this is going to the LFI amplifier unit. Basically this is supplying the power to amplifier unit. Now I have one simple animation so that you can understand in easy way that what is actually F3 to F9. So here I have taken a bulb of 24 volt DC. If I connect this bulb to any of the channel from J3 to J9, then my bulb will be lighting. So you can see here, just I have connected to the J7 and my bulb is lighting. So you can now understand that it is just supplying 24 volt DC and nothing else. Okay. Now we are moving to next, that is F12. F12 is located over here, and this F12 supplies power from channel number 20 to channel number 37. These channels are basically analog input channels. Now we will see in the electrical diagram. So here this is the channel 30 and this is 24 volt supply. This 24 volt supply is coming from the F12, that is the fuse number 12. Okay. Now moving to our next fuse, that is F13. F13 is located over here, and this F13 supplies the power from channel number 40 to 53. But here you can see that this is also supplying the channel number 60 and 61, but actually this is wrong. Channel number 60 is being supplied with the F16 and channel number 61 is supplied with the F61. So you can see here like this, channel number 60 supplying with the fuse number 60, channel number 61, fuse number 61. Okay, so please take care of this one. Next is F14. F14 is located over here, and this supplies power to channel number 70 and 71. These are very important channel. So this fuse is also becoming very important. Now among all these fuses, only 4 number of fuses are important, that is from F9 to F14, and these are important fuses and hence scanned by ECS in all MPC. Failure of these fuses generates alarm. Please note, failure of these fuses from F9 to F14 generates alarm because these are connected to various channels, so they are very important. If something goes wrong with these fuses, obviously that concerned channel will also not work. Now we can see it with the example. Here you can see this is the CC1, fuse 12 failure, it will generate alarm, fuse 13, fuse 14 and fuse 9. So please check the stock of all fuses once you join the vessel. That means all these fuses must be in stock on the ship because all fuses are very important. Next we are going to talk about the terminal J10. This is terminal J10 here, and this terminal J10 function is connecting terminals loop. So this is J10 in the MPC. Now we are going to see where are they used. Whenever an external source or system wants to interact with the MPC and ECS, then it need to be looped. So in order to understand that, I will take you to the school time where you might have read about the following diagram, where 2 loops are there in which current are flowing in each loop without interfering other loops. So in the same way, suppose this is the FIBA and it has one unit which can bring FIBA in shutdown mode, and I want to give power from both safety system as well as the ECS. Then what will I do? In order to do so, I will use J10, and by using J10 I will connect both system in loop and I will give supply to FIBA. So here the J10 comes in pictures like this. You can see where these both different systems come together and do a common job. That is a function of J10. Now we are taking you to the electrical diagram. So you can see here, this is the J10 loop terminal. This is shutdown signal coming from the safety system. This is called the direct shutdown line, and this shutdown line is being looped at the terminal J10 at the pin A and B. So I hope this J10 is clear. J10 is nothing but a platform at which 2 or more systems can come together and assimilate with the ECS and do the common job. Now we will discuss about some terminology, like here you can see analog in, fast digital in out, dongle, battery, etc. So we are going to discuss one by one. Our first terminology is analog in. This analog in channels are 20 to 37, here 20 to 37. One thing I want to tell you that this picture has been taken from ME engine manual, but here this analog in is not 100% correct. Instead, these channels from 20 to 37 are also used for digital in, not only for analog in. For example, you can see in this picture that this channel comes under 20 to 37 and it is used for the digital in. Okay, now let's move. So what is the analog in? Analog in are the input signal which contains 4 to 20 milliampere, which is generated by the various transmitter and sensor like pressure, temperature, position sensor, etc., and feed to MPC in channel number 20 to 37. So this is the analog in, means 4 to 20 milliampere signal. Now we will see it by the various example. First example is a start airline pressure transmitter. It senses the around 20-30 bar start airline pressure, and this gives signal 4 to 20 milliampere to the MPC. Next one is, this is the HPS pump torque sensor, also generate the same 4 to 20 milliampere. This is the FIBA channel number 30 position sensor. This also generates the 4 to 20 milliampere signal. Next one is exhaust valve spindle position sensor. This also generates the 4 to 20 milliampere signal. All are the analog inputs. Now we are going to see our next topic, that is the galvanized isolated. What is galvanized isolated? If there are two or more systems, then they must be electrically isolated so that disturbance in one of the systems should not interfere with the other system. That is the idea behind implementing this galvanic isolation. Okay, now we will see with the example. In this diagram you can see there are two type of galvanic isolation. One is power isolation and other is signal isolation. In power isolation means I am isolating the power of two different systems which are somehow connected with each other. So here you can see that this is a PLC. So this circuit represent PLC and this circuit represent load like motor. This is magnetic coil, and if I switch it on, then this magnetic coil will pull these contacts and hence the supply to the motor will be established. So by this we can see that there is no connection between these two systems, but they are altogether influencing each other. So this is called the power isolation. Now we are going to talk about the signal isolation. In order to understand, I want to tell you about this circuit. This is a basic circuit and it works both for analog and digital input. Here if I give power to LED, this LED, then transistor will start conducting the current and current will flow from 0.5 to 0.4, and hence at 0.5 the voltage or current will change, and this change will be sensed by the input terminal of the MPC and further proceeding will be activated. So this part is representing MPC and this part is representing various sort of digital or analog inputs. For example, this is the pressure transmitter, it is representing analog inputs. This is the magnetic contactor, this represents digital inputs. This is a float sensor, so this one is a digital input. This is the temperature sensor, analog input, this is same, and this is also same, analog input, and this is a digital input. So these various type of inputs are there which is handled by this basic electronics circuit. This circuit basically does the signal isolation. We are now going to see in detail about the function of this circuit with some animations. Let's learn with the animation. Now here I want to describe little bit about this circuit. This is basically an animation. This circuit is related to the digital signal to MPC via optocoupler, means how a MPC sends the digital signal with help of these optocouplers, means using this galvanic isolation. Okay, here you can see that if voltage is greater than 10, it will sense 1, and if voltage is less than 10, it will sense 0. Means I am talking about the digital signal. MPC will understand 1 or 0 according to the voltage. Now if I make this switch on, then the current will pass through this diode, and this LED will impinge light on the phototransistor, and hence phototransistor will start conducting current from the collector to emitter, and here the voltage will drop and current will increase. So now I am here talking about the digital term. Digital means only switch on off. So here I will make this switch on and see what is happening. So now let's start. So here I am just switching on. Here you can see that light has come and voltage has dropped from 15 to 5, and earlier it was sensing 1, now it is sensing 0 because it is less than 10 volt. Now if I switch it off, then it will go in the reverse mode. So here you can see again it has come to the 15 volt. Now the input terminal of the MPC will sense 1. So this is how the digital signal works with help of galvanic isolation. So here there is a galvanic isolation. So now we are moving to see the same basic circuit in respect of the analog signal. Here this circuit is almost similar. In this basic circuit we can see that some amount of current is already passing through this diode, and some amount of current is already passing through this transistor as well. So here I am getting, for example, 4 milliampere. Okay. Now if I start reducing this resistance value, then current will increase and hence intensity of the light will also increase, and here the current passing through the transistor will also increase. Here we will see with the help of animation that if I reduce the resistance, what is happening to this milliampere. Okay, now see, this is increasing. If I reduce the resistance, it has increased from 4 to 20 milliampere. So, this signal here is going to input to the MPC analog channel from 20 to 37. So, these channels work like this way. So, I hope this much is clear that how a digital and analog signals is getting transmitted to the MPC with help of the galvanic isolation. That means if something goes wrong in this left side of system, it is not going to hamper our MPC, which is very costly. Only the optocoupler part will be damaged, and that can be easily replaced. Now moving to next, here I will show you in the electrical diagram that how the optocoupler is used. So here you can see that this is a cylinder oil level sensor. It is giving the digital input signal to channel number 21, and this 2 pin which is written in minus and in plus is connected to the optocoupler like this. It is passing through the diode, and hence this terminal output 8 and 7 is connected to the CPU. So if something goes wrong with this system, only this optocoupler will be damaged, my CPU will be saved. So that is the idea behind using galvanic isolation. So I hope galvanic isolation is clear. This is all about the galvanic isolation. So now I am taking you to the MPC board to see physically how the optocoupler look like. So here these are called barrier or optocouplers. Okay, now moving to our next topic, that is fast digital in. Before talking about the fast digital, we first understand slow digital. Slow digital means any digital signal generated from the mechanical contacts are called slow signal. For example, if this is the relay which I have shown here in working condition, means making and breaking the contacts. So if I want to operate these contacts 20 times in a second, I cannot make it because this is mechanical. This has several mechanisms, and there are delay obviously. So even though I switch on switch off power to this magnetic coil, I will not get 20 times make and break of these contacts because of some mechanical delays. So that is why these are called the slow digital input. That means all mechanical equipments which generate digital signal, means making breaking the contacts, will be termed as a slow digital input. Similarly, same thing, this is the contacts of the magnetic contactor. This has also the same problem, means some inertia is there. So we cannot make it as fast as the fast digital inputs are there. Now moving to our main topic, fast digital input. So fast digital input switching is done by a solid state electronic component like this. These are the solid state which is regulated by the PLC, because making breaking several times we cannot do it manually. It must be done by the some PLC, some digital circuit. Okay, so fast digital is done via the solid state electronic component. So in this circuit, if I want to switch on switch off 20 times, I can do it. So now I am going to give you some animation so that you can understand that how this fast digital works. So here you can see that light will appear and disappear very fast. So you can see like this. So this is how the switching is done in the fast digital input. I hope this fast digital input is clear. Now we are moving to see its example in the ME system. So only one example is there in whole ME engine system, that is called the tacho system. In this tacho input there are 8 channels from 40 to 47, and all channels are fast input because it generates digital signals on and off very rapidly and sent to the ECU and CCU. So only one place is there where you will find the fast digital input. Rest everywhere you will find slow digital input coming from the relays, contactors, switches, etc. Okay, so now we are moving to next topic, that is fast digital in out, which is related to channel number 48 to 53. So this is channel number 48 to 53. These have 5 pin configuration, and other channels have 4 pin configuration. Here some are having the 2 pin configuration. Only J10 has 10 number of pins. Here in channel number 60 and 61 you will find 8 pins are there. So there are quite a difference between these channels and these channels. So we are just going to see what are the differences between the 4 input pin configuration and 5 input pin configuration. So these are also called the high load driving channel. So here next topic is a difference between 4 pin and 5 pin configuration. So now here this is the electrical diagram of the CCU. So here channel number 21 you can see there are 4 pin, whereas in channel number 50 there are 5 pin. So what is the major difference between these 4 pin configuration and 5 pin configuration? Here also 24 volt operating voltage is there, here also same thing, but you will see that configuration is different. So just we will see that what is the differences. In 5 pin configuration, it is used when high load is connected to the socket. Second is supervision of wiring is needed, means if you want to supervise this wiring, that means whether it is disconnected or not, then you need to have a 5 pin configuration. It can be done also in 4 pin configuration, but 5 pin configuration is better than 4 pin configuration in terms of the supervision of wiring. Okay, now next one is supervision of voltage is needed. Now this is important little bit, so just we will understand by channel number 50. So here you can see that voltage is coming from some other place. Now it is coming and it is entering into the J50V in through the jumper, but why? Here you can see that 24 volt is straightway coming from this channel, but here 24 volt is coming from the outside. That means this channel is programmed in such a way that, for example, if voltage goes below 20, then you please stop giving supply to this starter pilot valve. Got my point? That means here what I am doing, I am supervising this voltage. I want to make sure that before supplying this starter pilot valve, this should be 24 volt or for example say more than 20 volt. If it is less than 20 volt, I will stop supplying this starter pilot valve. This is called the supervision of voltage. This supervision of voltage are at so many places in the MPC. So you will come to know when we will discuss in electric diagram, then I will tell you wherever it will be there. Okay, so this is all about the 5 pin configuration. I hope you have understood. Now we are moving to next topic, that is the various connection of MPC. These are very important. So now here I have a diagram. It is representing the multi-purpose controller. It has several inputs and output. So this is just a barricading between the input and output, this black line, and here it is showing that what all are the external connection is there into the multi-purpose controller. So now we are going to see one by one all the component of the multi-purpose controller. So our first is power input A and B. This A means it is coming from UPS A and this is coming from the UPS B. So we will see that where are they located in the MPC. As I have already told that this is the our main power input socket J1. This is basically the power input from UPS A and UPS B. Now next is other computer equipment. Other computer equipment is the serial communication. That means this MPC is designed to communicate with other computer also. So this serial communication is located over here. Okay, this channel work on the serial communication 485, 422 and 232 like that. Now moving to next, this is two network cable A and B. So network cable are located here. These are socket for the network cable basically. Now this is the key plug. Key plug means dongle or ID key. So ID key is socket is here. Next, This is the access by authorized service personnel only. That means the man B&W servicing engineer will come and they will connect their laptop to this port, and hence they will come to know all about the MPC, that where are the problems, and if they need they will upload the new software. Next is contacts. These are the digital input. By seeing this symbol you can make out that this is the slow digital input. So now we are going to see the example of these contacts which is used in ME engine. Here this is the main magnetic contactors, this is the power input terminals, and these are the power output terminal which is connected to the heavy loads like motor. These are called auxiliary contacts. These auxiliary contacts is used to send digital signal to ECS about a status on, off, open, close, stop, run, etc. Now here I am representing the same picture. Here you can see that between point 1 and 2 it is representing a switch, and this switch is nothing but a contacts of these auxiliary contactors. I hope you understand. Okay. Now these are symbolized like this, open and close contacts. Now here we will see that what all others devices are used for giving digital inputs. So here you can see these are the magnetic contacts, relay, various kind of relays are there. This is also a relay and this is a timer relay. So various this type of relays are also used to give slow digital input to the MPC. Now we are going to discuss about magnetic contactors. Here this is the internal construction of the magnetic contactors. So this is moving contacts and these are the stationary contacts. So when this magnetic coil will be energized, then it will pull this moving contact and hence these both contacts will be closed. Presently it is not closed, so it has shown by this symbol, and when it will be closed then it will be shown by the straight line. Okay, so this is the diagram of the magnetic contactors, moving contacts, stationary contacts, power input, power output and magnetic coil, and this is a fixed armature, this is moving armature. Okay. So now we are taking you to the animation part of this magnetic contactor so that you can understand how an auxiliary blower HPS pump start stop signal is generated, transmitted to ECS, and we get information over MOP for the same. So here this represents the auxiliary contacts that I have already shown you, and regarding this I have already explained. So presently these two contacts are open, so this symbol is there, open contacts. When this moving contacts will come down here, then this both contacts will be closed and this will come to here. So at present this is showing 0, means digital input is 0. When this will make to here, then it will become 1. So now you can see the animation. So here power supply has input, now it is moving and this contact is closed now and it has become 1. You can see one more time. When I will give power supply to this, it will start moving, hence this will also move, and since this is representing this, so this will also close. So see one more time. And it has become 1. Now we will see some example from the MOP screen. So here this is the same magnetic contactor. This magnetic contactor is from the auxiliary blower. So here you can see that presently this is open. So here it is showing in a stop condition. Now if I make it on, then this contacts will be in closed condition and here the information running will be appeared. Now here you can see that this is now closed. So here this running information has appeared. So this all sort of information comes from this type of contacts. These are the auxiliary contacts, relays. So I hope this is clear to you. Now moving to our next component. So here it is showing a plus minus 10 voltage. So these are called either fast digital input or voltage input. So we have already discussed about the fast digital input. Now here we will see the voltage digital input. Both are same. So now we can see over here, mostly used for digital feedback sensing and wiring supervision. Okay. So now This is the same kind of circuit, but here I have not shown optocoupler, just I have given a raw diagram that this is a 24 volt DC power source. Here resistance are there, these are resistance. If I don't make these contacts, then some current is passing through this PLC directly or from the optocoupler, so it will show some voltage, and this voltage will be sensed by the PLC input. So here I have made a program that if voltage is less than 15, consider 0, and if voltage is greater than 17, consider 1. Okay. So here if I make this switch on, then what happens, that most of the current passes through here and large potential drop at this point. Hence the voltage drop from 21 to 10. Now my PLC will sense it as a 0. So this is the same way that what we saw in the optocoupler circuit. So here I have just tried to make you understand that what is the voltage digital input, means any voltage will be programmed like this, and the PLC will sense changing in the voltage in term of 1 and 0. Now moving to our next topic. This is X/I. X stand for anything like pressure, temperature, position, etc., and it is converted to I. I denotes current. So this is 4 to 20 milliampere. That means these are the analog input signals. Now here we will see some example of this type of inputs. Here this is channel number 30, 4 to 20 milliampere input. Again this is the exhaust valve spindle position feedback, channel number 34, CCU 4 to 20 milliampere input. This is hydraulic oil inlet pressure, that is around 2 bar, channel number 32 of all ECUs. Next component, that is tacho. Tacho is used for the fast digital input. So here these are the tachos, tacho A and tacho B. So they send fast digital input to channel number 40 to 47. Now moving to our output section. So here first output is this is showing the channel number 48 to 53 high load digital output. That means if you want to operate any solenoid valve or any IP converter like that, then you need to have a high load digital output that is driven by the channel number 48 to 53, and symbol is like this. Okay, now moving to our next output, that is called the slow digital output, which can be understood by seeing this symbol. Switching on off like HPS pump, auxiliary blower, etc. So that channels will be denoted by the this slow digital output. Next is this is plus minus 10 volt. This is fast digital channel, fast digital output. Next is this is the reverse of this analog input. This is the analog output, 4 to 20 milliampere, and that is driven by this channel number 70 and 71. So okay, we are finished with this multi-purpose controller components. Now our next component is battery. So we will see the battery part. So this battery is used for the internal clock for the MPC series 2032 is like BR2032, CR2032, DL2032 etc. So you can use any of the battery. All batteries are of different milliampere hour capacity. BR2032 is the best battery for MPC. If voltage reduced to 2.7 volt, then change the battery. Usually the potential of this battery is 3 volt. So if it drop below the 2.7 volt, you have to change the battery. Life is around 3 to 5 years if no blackout occurs. So here this battery is located in the MPC. Just you have to pull this clamp and just take out the battery. Okay, this battery look like this, BR2032 3 volt. Okay, to renew the MPC battery, it is recommended to do it when engine is stopped. However, the battery serves as a backup supply for built-in clock of MPC and does not harm engine operation due to low battery voltage. So even though the battery voltage goes down, it will not going to harm in the engine operation. So there is no need to panic if you get the low battery voltage alarm. So here you will find this battery voltage low alarm is there. This alarm is available for all MPC. So when the battery potential will go down, this alarm will be appear. But no need to panic. You change whenever you get the time. No need to stop the engine and change the battery in between. Okay. So now moving to our next topic, that is the ID key. ID key is very essential part of the MPC. As name suggests, ID means it gives the identification to the MPC. So we will see that how does it look like. So this is the ID key. Now we will see regarding ID key. This ID key contains program chip which downloads the required program from network and give identification to any MPC as CCU 1, 2, 3 like that, ECU A, B, EICU A, B, ACU 1, 2, 3, SCU 1, 2, SCR etc. So here repeating once again, that means when we install new MPC, then its identity is only MPC. But when we connect ID key, then its identity changes to CCU 1, 2, 3 like that, ACU 1, 2, 3, EICU A and B, ECU A and B like that. So I hope you understand that what is the function of ID key. Now all MPC are having individual ID key and there is no spare kept on board. Please remember, all MPC are having individual ID key and there is no spare kept on board. So this ID key is secured with the metal wire and you are not supposed to remove this ID key from this cabinet. Also never ever try to interchange any ID key from other places. So now in term of ME engine, any MPC first identity is MPC and its second identity is CCU, ECU A, B, EICU A, B, ACU, SCU, CWCU etc. So I hope this ID key is little bit clear. Now we are going to understand with some example. Now here in this picture, this is CCU 3 and this is MPC, new MPC is kept on board just for a spare. I have some doubt so that I want to replace this CCU 3 to this new MPC. So what I will do, I will just simply remove this CCU 3 and I will put this new MPC in place of CCU 3 and hence this MPC will now become CCU 3. Okay. Now here I am going to use this removed CCU 3 again. So here this is the removed CCU 3 and here it is a EICU A. So now I have again doubt on this EICU A. So I want to replace this with removed CCU 3. So presently if I ask you what is the identity of this MPC, this removed MPC, then what will be your answer? Even though it has been taken out, its still identity is CCU 3. It is no more MPC. Have you got my point? But when I will fix this CCU 3 in place of EICU A and I will connect this dongle, this CCU 3 will become EICU A. I hope you understand that how this MPC identity is being changed with help of this dongle key. Now moving to our next topic, that what to do if ID key is corrupt, because as I have told that ID key is not kept on board as a spare. So if ID key is corrupt, then what will we do? If concerned MPC is still working, then no problem. Only you will find that alarm is coming that ID key is corrupt. But ID key's job only to give the identity when the MPC is replaced. After that it has no job at all in the MPC. But the alarm facility has been given so that operator come to know that ID key has corrupt and need replacement. So in that case no need to try replace MPC, because when you try to replace MPC you cannot do it without the ID key. Okay, so let the ship run like that only. If MPC is also defective along with ID key, then cut out that unit and run the engine at reduced load. The cutout you will do in case of CCU only. If it happens in the ACU, then discard that ACU, and if it happens in EICU and ECU, then obviously you are having already a spare one. That is, if ECU A is defective, then ECU B is already in working condition. So there is no need to worry. Immediately contact MAN and B&W. They will supply at next coming port. They can arrange to supply at world almost all port. So if ID key is corrupt, then immediately you should put the message along with your ETA, then they will immediately supply this ID key. Our next topic that is deep switches. So here we will see what are their function. So there are two type of deep switches installed in the MPC. One is installed on the motherboard, that is called the deep switch A. In this deep switch, except 1 and 8, all switches should be off. This is its default combination, and this deep switch is especially for network for the whole MPC. Okay. Now another type of deep switch you will find installed on the input output card. This is called the deep switch B, also called S1, and in this deep switches all switches should be in off condition. Here you can see that all switches are in the off condition. Okay. So this deep switch B is especially for the ID key or dongle. That means this deep switches basically configure the ID key or dongle function. Okay. Now we are moving to our next topic, that is type of defects in MPC. This is very important, and here we will see what are the defects and what are the remedies, how can we tackle all those problems. So various type of problem can occur in the MPC. For example, power card defective, motherboard defective, input output card defective, any one or more channel in input output card not working, daughter card defective, any one or more channel in daughter card not working. Now here we will see how to repair a defective MPC. So now we are going to refresh one more time about the various part of the MPC. So here you can see that this is the power card, this is motherboard, this is input output card, and this is child or daughter card. Now here we are going to discuss some fundamental thing. So first one is except motherboard, all three cards means power, input output and child or daughter cards are interchangeable, means you can interchange these card from one MPC to other MPC, whereas these are not recommended, but all these things you can do only in case of emergency. After exchanging the card, do not use it as EICU, ECU, CCU, but can be used for SCU, SU, SCR, otherwise warranty issue of engine may arise. I have already told that this thing you can do only in case of emergency, in the case that you are not left with any spare MPC and somehow you have to run the engine. So if you have 2 or more defective MPC, then you can at least repair one by exchanging all this card and you can run the engine. Okay. Now we will see this with the example. Suppose CCU 4 is defective and you have repaired one MPC, then take out any SCU or SCU and put in place of CCU 4. That means they are good MPCs, SCU, CCU, which are already in working. So you have to put them in place of CCU 4, and the repair one MPC you put in place of the removed one from SCU or SCU. I hope it is understood, because SCU and SCU are not so important MPC. They can run with the repaired one, no problem, but since these CCUs are very important because they take part in the combustion process, so if it will be repaired one or some alteration is done, then obviously warranty part will be compromised. Okay, now next is these repair can be exercised only in case of emergency, as I have already told that you have to exercise only in case of emergency. Now here you are going to see some case study. So case 1 is this is a defective MPC. Its channel number 70 is defective. Channel number 70 is defective means you have to discard this MPC, you cannot use it. Okay, so this is the number 1 defective MPC. Second defective MPC is its power card is defective. Okay, power card is defective. This input output card and outer card, motherboard, etc. all are okay. Okay, so how will you repair this card? Okay, so here you can see that this power card is defective, but here in this MPC power card is okay. So what can you do? Just you take out this power card and you install here. Okay, remove this power card, take out this power card and install this power card into here. By this you can make this MPC operational. So okay, so this one was the first case. Now we are going to discuss case number 2. Here again this is the defective MPC. In this MPC, child card all channels are not working, means this is the child card or daughter card, all channels are not working. Okay, and another MPC I have in which input output card no channel is in working condition. Okay, so in that condition what should I do? Here you can see that in this MPC child or daughter card is okay. So in that case what will I do? I will just simply discard this child card and I will take out this child card and I will put in place of this card, and hence I will make this whole MPC operational because my power card is working, my this input output card is working, motherboard is already working, only this was defective. So I just replace this card from here and I have made this card in working condition. Now I think you have got a fair idea about how we should proceed for replacement of all this card. Okay, now moving to our next topic, that is how to reset MPC. So there are 4 ways to reset the MPC. In first method, when any MPC will hang, then you will find this sort of alarm appearing on the MOP. So here what we will do, just you reset this alarm. When you will click this, you will find one reset button will appear over here. So you just simply click it, you will able to reset the MPC. That is called the soft reset, means you are doing with the help of software and with the help of the MOP. Okay, now we are moving to next, that is about the checking fuses. So basically a lot of MPCs are hanged because of the fuses, means fuse will blown and they will hang, and also the alarm will not appear because they are in hang condition. So second thing is you should check all these 14 fuses. Okay, check all these fuses and replace if necessary, and then you will definitely able to reset this MPC. Now third one is manual reset. So here in the MPC left side of the MPC box, you will find there is a black color reset switch is there. If you press this reset switch for 3 seconds, then this MPC will reset automatically. This type of reset is called the manual reset. Now we are moving to our fourth option. This fourth option is called the hard reset. Hard reset means you have to take this power supply off from this whole MPC board. That means you are disconnecting the power of the MPC. So unplug the power supply from UPS A and B and keep it for 3 minutes and then you reconnect it, and by doing this your MPC will be reset. Alternatively, you can switch off the MCB from UPS A and UPS B of the particular MPC, keep the MPC off for 3 minutes at least, then switch it on again. So there are 4 methods by which we can reset our MPC if it get hang. Now next thing is that sometimes MPC get hang and series of alarm will be appeared in MOP. For example, we are taking CCU2. CCU2 get hang, so we will see what sort of alarm will appear. So first one is SCU2 abnormal, no communication with CCU2, CCU2 tacho feedback error, and many more. Okay, so how will you proceed? So I am just summarizing the same thing which we have learned just now. So in some cases, the concerned unit or channel of any MPC like ECU, EICU, CCU, SU, SU or some particular function will not work if MPC in hang condition. That means the MPC is hanged, but you will find some of that MPC channel are working and some are not working. That is also called in a hang condition. For example, in case of SU1 hang, the auxiliary blower number 1 is getting a start stop via channel 82, but is unable to control the load of HPS engine driven hydraulic pump via channel 70. Means 70 is not working, but 82 is working. This is also a kind of hanging. Means your some channel will work, some channel will not work. Okay. So how to proceed for the solution? First one is check fuse number 14 if okay. Reset the MPC manually if problem persists. Conduct input output test for channel 70. It will definitely tell you what to do next with the MPC. If input output test is successful, then probably problem is with the external wiring of the concerned channel. If external wiring is also in good condition, then conduct the hard reset. If still problem persists, then change MPC. This will definitely sorted out your problem. So now we are end up with the part 1 of the chapter 5. So I hope you enjoy whole session of part 1. You might have got a lot of knowledge, and definitely it will improve your proficiency level. So thank you for watching this video. The end. Bye bye. Take care.